Good afternoon all. I'll start my presentations from GEOVIA Solutions. So in GEOVIA Solutions, we can split in few parts. First is the earth modeling part. Here we can import the survey data and create the DTM digital terrain model for volume calculations, for contouring, for sections in any orientation, and then import geological data informations here. Suppose color survey assay geology, create the borehole database and solid model, block model estimations, and validation and resource reporting. This part is totally take care by the earth modeling part.
That is the most important thing actually.
Okay, Aniket, I'll continue.
99 log.
No.
100 okay, sir. Sir.
In next part is the earth design and engineering. So here pit
Yes, sir.
design,
I am
dump
on
design,
okay, sir.
road design, and blast design for open cast underground design. Also, it's possible. Suppose
Okay, sir.
stope design, cross cuts, underground ring design, and everything. And reserve we can calculate. And third part is the earth resource management for production planning, for short term to mid term to long term production planning, and manage all the aspects and day to day scenario we can develop from here up to the end of life of mines. So GeoVia solutions are divided in these three parts. So Surpac software is the point solutions here. Uh, Only Surpac software capable to handle the survey data, geological database, and geological modeling, and opencast underground design and reserve calculations. Next one is the mine scheduling software. So mine scheduling software basically used for scheduling purpose, earth resource management. And next one is the Whittle. Whittle basically developed on mine economy to calculate the NPV and IRR value, and economically scheduling also possible through Whittle software. And next point solution with us in Minex. Minex basically used for stratified deposit like coal, phosphate. So through a single software Minex, we can handle entire thing, but it is basically specially for stratified deposit, and fault model is very strong features in Minex. So through our point solutions, we can handle entire thing, end-to-end solutions from discover, borehole planning to execute and everything. Borehole data we can import, create the database, evaluate, establish, extract for opencast from underground, beneficiate related informations, selling and rehabilitations. In entire flow chain, the modeling part and planning part is totally covered by our point solutions. Borehole database, solid model, block model, estimation, opencast, whole road design, dump design, blending, strategy planning, tactical planning, everything is possible. Not only for opencast, underground also we can cover here. So in today's session, I'll cover the estimation process in using the Surpac software. So first, I'll describe the process flow of the estimation for the estimation. First, before start the estimation, first step is the prepare the geological database. Import the collar, survey assay geology, and create the needle-like structure, and create the geological database first. Next, create composite to normalize the sample length, and then basic statistics to know the behavior of the samples or range of the samples and accumulation of the sample range. And then start the variogram modeling to search the exact validate parameter. After validation, we can fix the parameters like plunging, bearing, deep, measure, same measure, measure minor ratio, nugget, seal, range, and everything. And if it is fixed, then we start and change, identify the domain, and then we can start the solid model after sections, then block model validations, and block size we can decide, and then resource estimation using the inverse distance method or kriging method or nearest neighbor or ordinary kriging or simple kriging we can use for the estimation process flow. And after estimation, it is very important to validate our estimation process through swath plot or trend analysis, and then generate the geological report standard geological report based on different aspects, based on the distance, based on the RL, based on the section wise, lithology wise, grade wise reporting. It is possible here. Standard report we can generate in any time after estimation validation. So this is the estimation process flow. So first we can create the geological database where color CSV file you can create, means with coordinate. Then survey file, if it is vertical borehole or inclined borehole, survey information is very important for boreholes. Then assay informations, radical informations, and geological informations all together we can assign in assay file and create this type of needle-like structure. After that, we can manage our drill hole, create the composite or normalize the sample length, geological interpretations, and geological report also we can generate from here, and create the graphical log. Individual borehole plotting is called graphical log, and normal plotting like surface plan plotting or section plotting, it is also possible. So after import the assay file, then we can create composite like this with our cutoff grade. We can identify the high grade zone, low grade zone also above the cutoff grade, and weighted average grade we can display beside the borehole. So we can easily identify the ore zone and west zone portion easily and start to digitize the section. An individual borehole log we can create to identify the exact our target location before start sections or basic statistics. So next part is compositing. Composite we can create for normalize the sample length. So here composite, different type of composite we can create through the Surpac software. First one is the composite downhole, is a very popular compositing method. So here composite length down a drill hole, we start from top and it is going down only. Then next one is the composite by geology. Based on the geological code, we can assign the geological, suppose steel gray hematite, blue gray hematite, blue dust, BHQ, BHJ. The litho wise, we can create the composite file. Then grade wise compositing is a grade constant, high grade, low grade, medium grade. Based on our target grade, we can create the composite and then start to estimate. So in that case, we can avoid the dilutions of the grade. Next composite type is composite by elevation. So bench wise compositing or stope wise compositing, we can continue through these options. Elevation compositing option, through the elevation compositing option. Next one is the composite by zone from to. We can define 2 3 geological zone in a particular domain or particular area. So in that case, geological code to the top and bottom of the another. So if you mention, then composite will be created automatically. Suppose topmost lithology is different, bottommost lithology is different. So I can assign the topmost lithology and bottommost lithologies automatically. It create the composite within this zone only. Next compositing is the composite multiple element compositing, is the several different compositing criteria we can involve here. Suppose in limestone mines, their CO and MgO both are very important to identify the ore zone area. So in that case, we can create composite based on two radical, suppose CO and MgO cutoff grade, and then create the composite and then start to estimate to avoid the any type of outliers from my samples or dilutions. Then another compositing method is from to end of hole. So it is going upward. So start compositing from bottom of the borehole and then it is going upward. This is the opposite, completely opposite of the downhole compositing. So these 7 type of compositing we can handle through Surpac software. So next, after compositing finalizations, then few things is very important in basic geostatistics. First is the histogram. So we can create basic statistic histograms to know the distribution of the samples, minimum value, maximum value, median, mean, median, geometric mean, variance, standard deviations, coefficient of variance. Through the histograms, we can identify and generate the report also. And this histogram we can visualize it is bimodal or unimodal. So contain two, in bimodal it is contain two distinct peaks, Each peak typically represents a different population, process, and geological domain within the data set. Next one is the outliers. So we should remove the outliers. Top cut is the process of reducing extremely high assay value from my data set. And then we can finalize the data, composite data, and start to create histograms and other variogram modeling, other step at the variogram modeling. But before start variogram modeling or basic statistics, we should know the outliers, and we can reduce and reducing the extremely high samples from my data. Okay, the next one is the cumulative frequency or percentile. QQ plot means Fe versus silica, silica versus alumina. This type of plot we can execute from the basic statistics window. So after compositing these type of histograms, bimodal, unimodal, outliers removal, and QQ plot, other than that, we can use this basic statistics window for block model validations, basic statistics calculation, and basic statistics report also. So then after histogram, we try to identify our deposit type. If it is isotropic deposit, in that case is the continuously distributed in all directions, and it is showing the similar behavior in 360-degree from no preferred geological directions it is happen. And same Vedogram model means single Vedogram model is appear in all directions. There are no variations, that's why single Vedogram graph is automatically come. It is simplify resource estimations and modeling, and uniformly search ellipsoid it is create. It means it becomes in spherical and circular shape ellipsoid. Circular shape ellipsoid means it's a major axis, same major axis, and minor axis. These three axes are similar to each other, and it is create a spherical or circular shape. And if it is an anisotropic deposit, so in that case spatial continuity varies with direction wise, so different rate of different directions. So features such as stratifications, fold, fault, mineralization, trend create the anisotropy behaviors, and identify anisotropic behaviors of the directional variogram model it will create, and improve estimation accuracy by using direction specific search parameter. In that case, our major axis, same major axis, and minor axis both are not similar to each other, and it is create a ellipsoid structure. In maximum cases, grade continuity is stronger in some directions than others. This is called anisotropic deposit. In nature, maximum cases we can face the anisotropic deposit only. So in for solutions is the better to go to the variogram model, and then we can identify which deposit is isotropic, which deposit anisotropic. So in that case, in variogram model we can create different type of variogram model here. One is the omnidirectional variogram model is basically used for isotropic deposit. Here major axis, same major axis, and minor axis, these three axes are similar to each other, and it is create this circular shape structure at the time of estimation process. And if it is anisotropic deposit, in that case directional variogram is the best option. In that case, is the variogram calculations along a specific direction, azimuth, deep, and measure uh, spatial continuity in a special in a certain directions. In that case, major, same major, and minor axis, these three axes are not similar to each other, and create a ellipsoid structure and start to estimate in a particular directions. So grade distribution will be more accurate in that case. Not only that, if it is isotropic, so go through the omnidirectional variogram. If it is the deposit is anisotropic, in the directional variogram is the suitable method. And next one is the downhole variogram. So it is only applicable for sample pairing from the same borehole only to vertical or along the borehole, to commonly use for estimate the nugget effect, to know the nugget effect downhole variogram model. The fourth variogram model we can create the indicator variogram model, is a specialized variogram modeling technique we can use for indicator kriging or multiple indicator kriging method, estimation method. And this indicator variogram we can execute based on the my cutoff grade basis. Suppose in case of the iron ore, 45, 55, 58, 62, 65, we can use those cutoff grade and create the indicator keying. Each cutoff grade wise, we can create that separate VGM file or barogram model, and then we can execute those informations during the estimation method or estimation process. So in barogram window in Surpac, we browse the composite file, then put the string range, plane deep direction, number of barogram, lag distance means borehole to borehole distance, spread value and spread limit also, and then create different uh, graphs with semi-barogram graphs here. The first we can create the major axis. After finalizes the major axis graph, then jump to semi major and then minor. So uh, after choose all those things, then we can put the model to normalize the graph and identify the parameters. So after identification of the parameters, then we can start to validate. During the validations, residual graph is a play a major role to validate our variogram model. And not only that, variance, average creek variance, two standard deviation also indicate that the our variogram is correct or not. If it is correct, then we can fix our parameter like planche, bearing, deep, major, semi-major, major, minor, and their seal, range, nugget. These informations we can fix for estimation. So if our variogram model is not validate, so we can try it from beginning and then try to validate first, then fix the parameter. So common reasons for poor looking variogram. So few points are very important before start variogram modeling. First one is there not enough samples, maybe so few samples, maybe if it is less than 500 or 400, so it is very difficult to fit our variogram model and validate them. So next one is the heterogeneous data, our not to be uniformly distributed our data in overall the field, and correlation is very poor. In that case, the geological, mineralogical, and structural differences may influence the data, and it is very difficult to fit and difficult to identify our proper orientation of the deposit or domain, and we can't fit our model and validations. The next point for poor looking videogram is the videogram parameters are wrong. If it is wrong, so maximum, minimum, class size, lag distance, if it is wrong, our input value is the wrong. So in that case, it is not possible to create a good videogram model. And poor sample data, the collection of the sample data or input data, if it is wrong, so we can't identify the nugget effect or range of the deposit. In that case, the major, semi major, and minor axis is not um, properly identified, and then our ellipsoid will be wrong during the estimation process. And data need trimming is very important to start before start the variogram model, or we should remove the outlier first, means extremely high samples which is beyond our range, so we should remove those sample first and start to variogram model. So these points are very important before start variogram model. If you want to create a good variogram model, obviously you first rectify your data, we cross check, double cross check your input values, and then start the variogram model and validations. Then after barogram model and validations, then sections based on the lithology or based on the grade is very important, and then create the solid model. So few technique in Surpac, common technique is automatic or semi-automatic solids we can create, and using the shape tool also, and bifurcations, child, parent combinations also we can use to create a good solid, and string morphing we also we can apply for these, and then validate the solid repair options is advanced tool in Surpac software. Within few seconds we can validate our solid and calculate the volume also. Then Advanced options, it is in solid is mesh tool. In the string morphing, we can create several sections within two sections to create a smooth solid. And expanding and contracting solid also we can create dilutions uh, envelope or ore loss envelope we can create easily based on these mesh tool options. And we can simplify our solid. If it is reduce the number of points triangle from a solid, we can reduce, and we can change the number of solids, so number of triangles and points without changing a geometry. No compromising in geometry. So after solid model and validation, the next is the block model. So we can create a to entire envelope for a area within the lease boundary, obviously within an area, lease boundary area. And then we can create a block model .mdl file with user block size. The user block size may be 1/3 or 1/4 or 1/5 of the borehole spacing. And then the z value is similar to our bench height. But sub-blocking options also available in Surpac software to increase the accuracy. Next one is the attribute. So many attributes we can create in block centroid. 512 attributes we can create in block centroid. Suppose Fe, silica, alumina, L code, character value or real value, both we can apply here. And then constraint creation below the topography within the lease boundary, or high grade sample, medium grade samples, or lithology wise we can create the constraints. And then estimation. In estimation we can create different type of estimation method with us. Suppose inverse distance method, ordinary kriging, simple kriging, nearest neighbor, indicator kriging, dynamic anisotropy method also we can apply here. And column processing is another options to calculate the thickness of the ore body, minimum thickness and maximum thickness of the ore body. And finally we can generate the standard report file format. So first is the inverse distance. Here is a simple and wild use spatial interpolation method, and unsampled locations are estimated by the nearest sample data, and it will be distance only, inverse distance method. And it is commonly used for grade estimations and surface modeling. So here in surface steps, here we can browse the composite first and then browse the constraint here. After add, then go to the next step. Now put the parameter which is collect from Vedogram modeling, validate after validation obviously. Put the bearing, plunge and deep value, measure, say measure, ratio, and then click on apply. Then inverse distance power is 2, and click on apply and start to estimate. This is the process here. So next is the ordinary kriging, is the another estimation method. And before start ordinary kriging, we should create Vedogram model first and validations. After that, that only we can run the ordinary kriging here. And it is define search ellipsoid first. This is the major axis, same major axis, minor axis is very important to start the ordinary kriging. And nearby data point and assigned weighted based of the estimation method, and calculates weighted average to obtain the block values. It is distributed. And Surpac workflow also is there. The estimation ordinary kriging, choose the attribute, proper attribute, suppose Fe, then click on apply, browse the composite file with string range, put search the constant data, browse the constant and put the values which is collected from the Vedogram model, and browse the VGM file. VGM file is created from Vedogram model, and then put the report name with formats and click on apply. So this is the process of ordinary kriging estimation process in Surpac. So another process, estimation process is nearest neighbor. This is the nearest sample point only it is considered for nearest neighbor estimation process. No averaging here, only closest samples it is allowed for estimation. It is simple and faster estimation method, and it is original sample values is automatically come and quickly it is estimated. Quick model generations and validation purpose we can use for nearest neighbor. Not only that, it is some constant and conditions also there, so it will vary domain deposit to deposit, which estimation method you are using. So nearest neighbor is the very useful for pocket deposits. And next one is the simple kriging. Is the unsampled locations are estimated by these simple kriging estimation method, and it is calculate weighted average nearby sample data only, and provide smooth and reliable spatial interpolation estimation method here. The next is very complicated and powerful estimation method is indicator kriging estimation method. Here, single geological domain contain two or more populations, then only we can use indicator kriging. It is handle complex grade distribution better than other traditional method like inverse distance or ordinary kriging. So here we can see the geological uh, constant few parts, and I'll show you the steps in Surpac. Indicator kriging, browse the composite file, then browse the constant, the single constant, add, apply, then put the information, estimation information, browse constant again, and then based on the cutoff grade we can put the parameters: bearing, plunge, deep, semi-major, semi-major, major, minor ratio, and each and every cutoff grade wise VGM file is already created during the indicator variogram modeling, and we can browse one by one VGM file for every cutoff grade and execute this process. So it is very lengthy process and very genuine process for if you for geological domain contain two or three or more populations. So after that we can create the report like this based on the cutoff grade and generate this type of report here. So next estimation technique is the very popular worldwide is the dynamic anisotropy. The stored ellipsoid orientation informations we can collect from solid envelope, and those informations, deep directions, those informations we can estimate at first of all in block centroid, and then create a new attribute in block centroid, and then estimate like bearing, plunge, deep values for, and it is collect from solid envelope only. And during the estimation process we can use those attribute instead of single parameter. So it is very effective if your solid model is structurally disturbed, and following geological trend and structure it will follow. So it will be more effective estimation method, dynamic anisotropic, and a worldwide accepted method. Through Surpac software we can handle those technique also. You can see in above image the estimation is parallelly execute, but in below image, so we can see the estimation or grade distributions it is vary based on our structural uh, flow also it is indicate. So after estimation process, suppose in inverse distance kriging, nearest neighbor, or ordinary kriging, or in different method we can apply in block model. After that, validation is very important. Block model validations here, original mean sample value to the estimation grade or range of slice we can validate through swap plot only. So quickly compare and validate our data. So through swath plot, we can identify our composite value as well as our estimation value. So in that case, our block centroid are estimated using the inverse distance method or kriging method or ordinary kriging or simple kriging. After that, we can create this type of graphs, this swath plot, and then we can identify which estimation method or which estimation method grades are very near to our composite value, our raw data, and I will finalize those estimation method only for this particular domain or particular deposit, not deposit, this is a particular domain. And if it is lithowise and steel gray hematite or blue gray hematite or blue dust, there are different type of domain we can handle simultaneously, and we can create uh, videogram model for those domain and estimate one by one and check their validation, estimation validations after with our composite value. Then grade tonnage plot and relationship between using this grade tonnage curve is relations between the cutoff grade, average grade, and tonnage is the impact of different cutoff grade on resource estimation. It is shown the average grade increase, it is increase, so in that case cutoff grade increase also, and is the tonnage is decreased when the higher cutoff grade can apply. And here is it is assigned and selecting the most suitable mining cutoff grade. So here we can create this type of report. So here, if in iron ore, if I consider 45-degree cutoff grade, 45% cutoff grade, or 50, 55, 58, or 60, or 62, or 65, in that case, if cutoff grade is in higher side, obviously our cumulative ton of the ore is in lower side. Similarly, you can identify the average grade of the based on the cutoff. So this type of report we can generate through the grade tonnage plot, the graph as well as report also. Then interpolation is the module in Surpac software that provide advanced geotechnical functionality. So in that case, multi-element and multi-zone estimation process we can handle simultaneously. So in that case, suppose we have five composite file with me and five block constant with me. So in normal cases, we can estimate one by one. It will take time. So, but through interpolator module, we can run the entire five constraint with five composite in at a time. So we can I'll will try to this module, and it will save our time. And in that case, only two geo estimation technical method we can apply here. One is the inverse distance method and ordinary kriging. Both method we can apply during the estimation process. So here Surpac workflow is there. So this is the few tabs is there. First we describe the run, then browse the composite file one by one, lithowise. Suppose steel graphite, blue graphite, blue dust, BHQ, BHA, like this type of old lithowise composite file. If I create, then we can browse, and then apply the constant. Browse the constant file here one by one. After browse all the constant file, then choose the it is ellipsoid and octane, and minimum samples, maximum sample, minimum sample 3, maximum sample 15 is similar to our estimation process. And then search maximum samples per hole or maximum search distance, major axis, maximum vertical search distance, bearing of the major axis, plunge of the major axis. Each and every uh, parameter we can assign one by one. In search pass parameter, here we can choose the second pass, third pass also. Suppose a few blocks are in unestimated conditions in first attempt, In that case, also we can introduce the second pass and third pass during the our estimation process. These options also available in this module. And here we can apply inverse distance method or ordinary kicking. Suppose the two constant, the first two constant, inverse distance is suitable for that, and next three constant, suppose ordinary kicking is the best for this lithology. So simultaneously we can run the both in estimation method and put the parameters, cross check the parameter, first of all set up, then validate. Anything is missing, so this type of error is automatically come, and then run our interpolation method or technique, and this type of report is automatically come with our input parameter. If anything is wrong here, so we can change those values, and again you can run. So first pass, second pass, third pass, we can put the values like this, and then you can run the estimation process. So after that, after estimation and validation, then we can display our block lithology wise, color lithology wise, and grade wise. And we can see the how much of quantity of uh, lithology wise is there, how much quantity of high grade, low grade, medium grade is there. So we can easily visible in graphics. And then finally we can create the resource reporting. Suppose in resource reporting we can define the user defined report, we can generate in any time, define the template, litho wise, grade wise, rl wise, and section wise report we can generate here, and distance wise also. Here, based on the distance from borehole to 100 meter or 100 to 200-meter, measured, indicate, inferred, this type of report we can easily uh, create. We can identify the zone and then create the report. Not only that, also we can create the report based on the rl, means bench wise, litho wise, volume, tonnage, and radical value, average radical value. Similarly, section wise report also you can generate. Suppose section wise, litho wise, volume, tonnage, and fe, and specific gravity, average specific gravity automatically come. So based on our requirement, we can generate several type of reports. And distance wise also is very popular to identify the measured, indicated, and inferred category resources. And after estimation, validations, and everything, we can create the slice plan based on the lithology or based on the grade. So easily we can identify the high grade location and low grade location. If it is a high grade locations, we can bound through the string file and start to pit design. So this is the, from here we can start the open pit design. If it is underground, then we can start our underground panel design, cross cut, decline, and, and everything. So this is the slice plan, and level wise we can identify the behavior of the ore also.
So now I would like to thanks Anurava for a very insightful webinar today, and I'm very confident it was helpful for our audience today. I also would like to thank our audience for taking their time out and joining this session. If you have any further questions related to the subject matters or any other requirement, you can always connect with us, or our details are displayed on the screen right now. You can reach out to us at any time and we would be happy to address your queries. Please do keep an eye on our upcoming seminars and webinars. You can also follow us on our social media platform for the same. Okay, thank you everyone.